security. Should be able to go to questions from the audience. Just a general overview of how you think we should be thinking about security. Any thoughts on it in general?
Well, I think in terms of
yeah, let's go about that.
Okay. I think in terms of security, there's a lot of security that ought to be built into systems. And when you think that who are the engineers today and who are the engineers of the future, tomorrow, hardly any of the security issues are dealt with in undergraduate computer science or software engineering degrees. And one of the big issues, I think, is how do we actually get some of that security into the undergraduate degrees?
I guess one of the problems there is a lot of the textbooks are out of date because the technology moves really quickly, and you really need to keep buying books every year basically to pick up with things.
A different theory. My theory is that the people who actually know security are practitioners, and they're in the industry making money. A lot of money in many cases, and probably more money than maybe they teaching courses or writing textbooks. And I mean, I'm thinking it may take a little while before those people decide to sit down and write a textbook.
I think I can do this without the microphone.
Yeah, that's something we could
Okay. I'm going to throw something out here that most people probably haven't considered. I spent 7 years lecturing to first-year undergraduates all the way through to master's students. And if you're looking at the undergraduate courses, even in a 4-year program, most students and a lot of the courses that I've looked at are not ready to present defensive programming other than at its very simplest fundamentals until the late 3rd year or possibly the 4th year. So that leaves 1 year to try and teach the next generation of programmers and software engineers how to do security properly, how to design security in, how to get it right from the start. And that's not a lot of time. I don't know about people here, but I learned about security over a period of 3 or 4 years. And to address this at an undergraduate level is incredibly difficult. You just don't have time.
Right, but at least you can plant the seed, right?
You can plant the seed. The problem is that, unfortunately, a lot of these minds aren't sufficiently fertile to grow that seed. You can quote me on that. I think it's a very important, and I agree, it is important that we start to approach this from the point of view of let's get people thinking about this earlier. But I think it's going to be incredibly difficult to do anything more than get that introduction in. And security scares a lot of people. It's hard enough to keep the right minds in that field. It's not an easy problem to solve, but I think universities are a good place to start. If you accept, you're not going to get very far.
Your experience is still, perhaps?
Bill, could you stand up and turn around and talk to the crowd, please? Rather than wait for the mics.
If more of the security tools were open, we'd be able to use them.
We have market belief is what he's saying.
Yeah, actually, that was going to be one of my other questions. Like, how come, given that bug checking type of tools have, developed so much in recent years, how come hardly anyone uses them in practice? Everyone was like, yeah, is it a price issue? Is it, you don't care?
He said the people who are teaching don't know about these tools because they don't spend any time keeping themselves up to date.
That's the workplace.
Into their code.
That's for
and they have no way of the virus. That's the wet one.
Yes, not first.
Oh, well, someone quite dedicated to QUT. I've been in security now for 38 years, so the quality of power is interesting. But I've also explained something. I'm a board member of the Collective for Information System Security Education in the United States. Some years ago, about 15 years ago or more, the United States government recognised that there was a massive education problem that's been talked to in relationship to what they now call information assurance, education and training. Later as awareness, training and education in the United States. And that led to the formation of the Collective, which was to bring together industry, government and academia to try to get this problem underway. It also led to the Scholarship for Service program, where government basically said the only way to get universities to teach this stuff is to give them actual positions. So they actually sponsored scholarships specifically to US universities, which run for a four-year full sponsorship, full money, and you have to be an approved university organisation. At the present moment, we have about 65 universities in the United States who are teaching information assurance in the undergraduate and postgraduate programs. We're now moving into what's called the 2-year college programs. So there is a bit of a start in the United States. Not much here in Australia or just recently in the European community. They're thinking about a similar problem too. How do we address this problem? Again, information assurance, education and training down. I think basically, well, just last week, the famous statement from a manager of Microsoft, the quote was on CNN, it was in Newsweek, quite specifically the problem that occurred in the cryptographic integration into Microsoft Word. You may have seen this in the press. He basically said, look, the guy who got the Wi-Fi stuff knew nothing about crypto integration or security, and it was an absolute disaster. This is what we're saying. This is the Microsoft manager, okay? And I've really done it in the last couple of years with a few years of educating information security and assurance that I'm happy about the ways we're doing it. Now that's a supplier making the actual statements, okay? That's what we call it. So basically, what can we do? Well, essentially, I think basically it's up to government, first of all, to say that we acknowledge the problem. Nations are now dependent upon the information infrastructure. We have the information assurance. We will sponsor education and training. Universities won't do it by themselves. There's no money. The cash is not there. So they have to have some way of starting the whole thing up. They also need to have the right teachers in their teaching. But then a bit further, bear in mind, I was solving the wrong problem. Multics, 1967, recognized, for example, that you can't write a secure system. This is computer science and engineering using a bi-state memory. That's impossible. That's computer science, which then, of course, the architecture, which we know, the model ring structure, what's called memory typing, code segmentation, which we never saw in the Intel 286, chipset, etc., etc. The problem is, the industry totally ignored it. So we're finding a problem today where the underlying hardware architecture, which is still in there, by the way, it's still in there in the Core i7, it's still got all the rings in there, it's still got all the segmentation in there, except for 64-bit node. The 32-bit node is still all that nice architecture, totally turned off by Linux, totally turned off by Solaris, totally turned off by Microsoft Windows, okay? So we've got a problem. Even if we do produce the right underlying hardware security infrastructure, does anyone care? Well, the answer is practically is no, they don't. Okay, and we're stuck with a still base of dual-state structure. And that's going to be a major problem for us, I think, for the next 5 or 10 years. The question is, will the industry bring back what we used 30, 40 years ago, that you have to have a multi-state memory, you must have memory typing, to get around the problem? Well, maybe the answer is yes. We're starting to see it come back again. GemSOS has been, the GemSOS kernel has come back again. It turns on segmentation, it turns on rings in the correct way. It's a fully A1 available kernel. So we've got that now. It's starting to rematerialize again. So I'm really hopeful. The question being whether people like Intel will listen to what's new at the hardware architecture level, okay? Otherwise we're stuck with a disaster of Leo with its ridiculous 3-1 uses. we're stuck with this sort of mess that we've got ourselves into. So that's what with education and training. I'm not positive in the United States, and we do actually have the new US government-sponsored program under the Canadian, and we're waiting to see over the next couple of years whether under Obama we start to see that get some funding. I'm hoping it will. We're aiming for a $60 million staff fund for this financial budget in the United States to try and get information short education into a 4-year program in America, so that could be a good start. So I'm a bit more positive than I was 6 months ago.
There's only you on that.
Yeah, I would want to share different perspectives to that show by Barrett about the problem with teaching computer security in the academia. Maybe my perspective may be different. I'm from Argentina, so it may be completely different from the one that you have here. But in Argentina, something like 20 or 30 years ago, the situation was that less part of the people that were teaching at universities had as their main job a job in the industry. And they teach one course, a couple of courses at university. And that meant that for the most part, they were able to share the experience that they got from the industry in the academia. I don't know exactly whether the situation changed because of unemployment problems and so on, but the reality right now is like a large amount of the people that is currently teaching at university have that work as their main work. So it's no longer the case that they have experience in the industry that they can share to the academia. For the most part, they are taught in the academia, and what they share is what they were taught in the academia. So it's my impression that at least in our educational system, there's a link between the industry and the academia that is broken right now. And another perspective, I agree with that, what you said, that usually in the industry, you get paid much better than in the academia, but I think that there is another problem other than that one. That a large amount of people that actually work in security in the industry, in many cases they have touched themselves about the stuff that they work on, right? And in order to get a job in the academia, it's usually the academia looks at all different things, and not really the experience that you have in the industry, for example. As an example that I have, many times I have tried to push people in the university I work for in Argentina to get a few guys that work at a security company in Argentina called Security Technologies. Probably many of you know, they are a very successful company. And I tried to get the CTO of that company teach at the university. Now, the main problems that we found was that the guy was too young, he had not graduated, and problems like that. So actually, he would have had many higher chances of getting employed in a university if he had been 60 or 50, no matter what his skills were. I'm not saying that this is necessarily the case, but it happens a lot, at least in my country. Maybe your experience is completely different, but that's a problem that we do find. And the people that we do have very skilled people working in the industry, but somehow we don't have a mechanism in the academia to enable those people to teach. And that's a problem that I have found in the university that I work for. I mean, maybe here you have a completely different experience, but I'd like to share a different perspective. That is not necessarily that these people are getting more money in the industry and they don't want to teach, but sometimes that there is something missing there that enables these people to share what they learn in the industry with the people in the academia.
I just want to add something to that. And I'm speaking only on my experience directly. Another problem that professionals have when they do manage to be able to teach in the university environment is because most of those people don't have a PhD, there is an aspect of being treated as a second or a third class citizen. Now that's irrespective of your effectiveness as a teacher. It does flow on directly to your promotion prospects. And to be honest, after 7 years of doing that and getting disillusioned, I gave it up and came back to industry. And I mean, I can say that I thoroughly enjoyed 7 years of teaching, but everything else around that was just not worth it. And it's difficult to want to put back into the education system when you're up against hurdles like that.
Just slightly to a different topic. But on actual tools, I mean, there's some, if you look at the basic tools, like Malloc or Valgrind, not run over it. Valgrind is excellent at picking this up, which basically logs you into Linux on x86 or PowerPC as a dev platform. So if, for example, you have another dev platform, say Spark, and maybe Solaris, not quite any products for a company I may work for, having an absence of Valgrind on that platform means that there is no way in hell you can exclusively use that as a dev platform. So it means to do just simple things like that becomes quite hard. And then tools on top of that, for example, things to say you want to not overrun a character array. So you think, we're using a C++ compiler, standard string. And then you go, oh crap, I want to internationalize the string, so string is out. What do you do? Cry in the corner, as far as I'm aware. So some of those even like primitive programming language tools that just suck, or the tools are completely missing on a platform. So you're then trusting that, well, running Valgrind on x86 obviously means that we're not going to have any security problems on Spark, on Solaris. And hoping for the best, because no data structures or type sizes are different between the two, right? So there's basic things like that. So in other words, someone please port Valgrind to Spark and Solaris for me. Who cares what I was saying? No one
Speaking about platform support, there is a lot of value in taking your code and making it run in as many places as you can possibly. Because if you get it on a PowerPC, your car's going to be a different sign as to every other architecture. You're going to have alignment issues on Spark versus x86 and all that sort of stuff. For example, one of the guys in OpenBSD ported the operating system to the M88K architecture, and he was finding a machine-independent bug out every 3 weeks because of his machine-dependent work. So if you have the time, run it as many places as possible. Pick up Valgrind and pick up the architecture differences.
There's a difference between having it built and running test suite and actually testing that we're not still doing other nasty things inside. So we do build on Spark, Linux, Spark, Linux, PowerPC, Linux x86, Linux x86-64, Solaris Spark, Solaris x86, Solaris x86-64, and MacOS. We don't have any MacOS PTC machines, but Intel ones, and that gives a fairly decent test coverage. But some of these sort of oddity security things. I recently found seriously an off-by line out bug in decimal to string conversion routines that have been used for about 20 years. Where it just how can you possibly have a large decimal number and convert it to ASCII? You could make a lot of shit break with a suitable enough large number. So it's kind of worrying in the fact that I only have some of these testing tools and stuff like that. I keep an old PowerPC box exactly like Valgrind on. So if I find a problem on Spark, the first thing I do is I build a Linux PowerPC and I run Valgrind, which seems like an interesting way to program Spark.
Could another approach to this be that we don't use C and that we use virtual machines that do some of the memory management for us? Virtual machines are virtual processing. Okay, but it reduces the amount of code that has those exposures.
Everything's written in C eventually.
It sounds like this word you're looking for is Java, except it doesn't have a security hole. So yeah, there's still that primary problem there. Like, well, the simple Turing machine can work. Brain fog is an excellent.
John, you getting work done?
Yeah.
Well, I guess from some other people's perspective, keeping the virtual machine example, we building better routers. We've got 64 gigs of RAM to play with, and that's, we used to have 32 or 16 or down to 2 megs for our first products. We got no choice for a lot of the case to write its great C on weird platforms that don't have these tool supports. So, the static analysis tools are great, but so much of the tools is what everyone's working on, which is x86 or PowerPC. So yeah, a lot of it just doesn't exist.
Well, I'd like to ask another question from the panel about tools in general and what's available to developers. I have a feeling that a lot of the tools just aren't very usable. Just how much better could we make security in the industry if we could make our tools more usable, more available? For example, we've been talking about Parfait and tools for static analysis. We've been talking about we'll leave it at that. I'd just like to solicit some questions about some feedback.
What's useful for you?
I guess just usability. For example, this morning we talked about the whole reboot on Solaris, speeding that up and how it's made it a lot easier for kernel developers to test problems in the kernel space, or with drivers, for example, made it quicker. Here we've been talking about Parfait and how it's made it easier to analyse problems with upload runs in C code and things like that. That's sort of the feeling I have, is that the tools really aren't that accessible and usable. Or even for just a home user configuring a system to be secure by default. There's been a lot of improvements recently in that space, but you take the average Windows user and they don't know how to secure the system. We've got to make it easier.
So I guess there's a lot of different aspects to security. You would need different types of tools for the different examples that you give, right?
Sure.
But say we just look in the case of Parfait, right? It's purely looking at implementation type of bugs. The ones that you can take, like here's the module, we'll go through the code, we'll find what bugs you have in that code. Now when we started that project at Sun, one of the first questions that was asked is like, why are you going to embark on yet another static bug checking project, right? Because there's so many of these tools available out in the market. And so to us, it was, let's try and understand why is it that developers at Sun are not using those tools. And there were issues of scalability, precision, and so on that came into place. So we tried to address all of those issues, and so we're to the point where people are happy using the tool, like amongst like the small communities that we're forming within Sun. But we also looked at this issue of portability, right? And clearly, like tools available for Solaris are lacking compared to Linux in particular and other platforms. So, we've tried to make our tool portable, and we test on Linux and Solaris on Mac as a way of ensuring that the tool can run on different platforms. We can make patches available in the near future. We're working on that for various different platforms, and so then that can be made available to the community overall.
I guess that's exactly my question. You've made Parfait a usable infrastructure on Solaris. There could be more advances on Parfait, for example.
Sure.
You said you have to compile the entire code base just to analyse a new change to a program.
Right, you can
You
do
could do
that incremental, you can do it on the
stuff.
and so on.
Yeah, but you can make it more usable. It's like JUnit for Java, there's a framework to make it usable, and now people who do Java development, that's a given.
Right,
A lot of
you
JUnit
can
fixes.
part of the whole framework, yeah.
That's right. So I'm just sort of trying to feel
how we're progressing in that space, making things easier for our software engineers, something that you could teach in the first years of university about the role.
Are you asking how we're adding overhead to the process?
In a way.
Yeah, and whether we feel we're actually progressing down that path.
Yeah, I think there has been some progress in that area. And, Microsoft, one of their tools, pre-class, integrated into their IDE. And I don't know what their IDE is called, but it is there by default, so people can actually use it. But it's probably like the first example of commercial IDE that has one of these tools embedded into for developers in general. In the case of Prague, I guess that our focus so far has been more on the research side of it, because we're part of the research labs with the health division. But we're clearly looking at some of the usability aspects, so that what does it take for engineers to actually use it? What does it take for the tool to be embedded into the build process? Can it be run overnight? Right? Because all of these are different levels of granularity that we're looking at, but all of that can help overall.
My comment was just about the virtual machine question earlier, which is a great question, but I used to work at the Department of Computer Science at the Australian National University, and so I saw a change. They went to, they started using very high-level languages with automatic storage management in their introductory courses, and I then got to help someone who'd gone through a 4-year Bachelor of Software Engineering trying to understand why his callback-based C stuff that he had to use because that was what he had to write to, why he was getting weird errors, which turned out that, he was allocating stuff on the stack, and he didn't understand about, the fact that that stuff wasn't there when you returned from the routine, because in every other platform he'd used so far in his education, it was all magic. So it's like, but there's that's, if you try to educate people and say, well, here's the guts of the machine, and if you ever need to actually work with the guts, you're going to have this sort of level of rigor and precision and difficulty, and then maybe focus on getting the algorithmic expression in some nice high-level language. So I don't know, it's like the old MIT, first undergraduate program that had scheme and assembly. So algorithms and then the details, and you were never going to just assume magic happened when you were programming C. So that is asking a lot of commitment from the Kiwis, and math is hard and we'd like to go shopping instead.
Yeah, I think there's two aspects to teaching people about computers, and you've got the science side and you've got the engineering side. That's a lot of what people are talking about is like, well, we're teaching science and we're teaching algorithms, and then there's also the engineering side, which is kind of what we call hacking, I guess, in other circles. There's a really good book called Security Engineering by Ross Anderson from Cambridge, and I don't know what's actually been taught in colleges now, but I think it would be really useful if there was like a first year, just a general security engineering course that was available across disciplines, computer science, IT, even mechanical engineering, because it looks at a whole range of issues like, and some interesting stuff like how to break into voting machines, how to design controls for nuclear weapons, and just to get people's minds kind of thinking without any really deep maths or without having to really do anything except just start thinking. So I wonder if maybe that might help us to get something kind of interesting like that. And certainly there are textbooks out there. It's definitely a book that we should read.
So I'm just wondering how much of this is actually about the debugging tools and how much is about getting developers to build the security in mind from the beginning, to engineer their software with security in mind. I just keep thinking of all of the bugs that used to pop up in SendMail, and since we've had Postfix, which was written from scratch with security in mind, in that particular zone, there's now a lot less security problems. So how much of this is about teaching people how to engineer and design code to be secure from scratch?
Well, I think that was part of the idea of maybe trying to get people to think about security as a more general topic from the beginning, and not necessarily, until later they have to sort of tie things together. But yeah, there are people working on secure languages and secure operating systems that they're trying to make it impossible to make security errors, or very close to impossible. And there's some work recently, and I believe they're not here, in the NICTA people worked on the L4 microkernel, doing some security work there, being able to prove that the system is secure. So maybe down the track we're looking at having language environments and even operating systems, or at least virtual machines running on operating systems to address that. But again, yeah, it doesn't really make people think about security. I have to say one of the best things that I ever did was many years ago was a book called Writing Solid Code, which is just I think it was actually a Microsoft Press book, and it just kept hammering home all the way through, check return values from system calls and this kind of thing. And you'll notice a lot of new programmers don't do that, so because they're trying to simplify the code. But if you ever make examples and if you're ever dealing with junior developers, always make sure, always pick them up on this kind of thing, because it's a good habit to get into. Just that, okay, I've just done a system call, even if it's one that you don't really care about the return, you should check it anyway, and you never know that error that's coming up might be a security attack.
I wanted to comment on your previous there about the having a general security curriculum or secure computing curriculum in the universities. We're running a program with open source curriculums called JEDI, and for anybody who's willing to participate and create a curriculum for universities to use, we welcome you into. You can find us. We're on Kenai, and we're on a couple of other places as well. We started in the Philippines, and we've done a number of different curriculums, and we've used the Philippines, Brazil, Indonesia, Malaysia, Russia, China, and a couple of other countries as well. So we're very interested in expanding the curriculums we have, and if people are interested in working on a curriculum, and everything is complete open source using community. CC license for all of the curriculums we're developing. So if anybody's interested, let me know, and I'll be willing to put you back in contact with the people who are trying to do things.
With regards to security frameworks like SE Linux and the ones you have obviously Solaris BSD, how do you make these things usable? I've tried SE Linux before, and as long as you don't do anything that it wasn't pre-configured to do, it's fine. But as soon as you want to do other things, there's just so many concepts and things that you've got to try and figure out before you can actually do it, that most people disable it. So it might be really secure, but if people don't use it, it's obviously not useful. So how do we go about making these things secure and easy to use?
Someone's fine. What you do is you just invent a new simple security system. No, the reality is that this is like the core problem from our side of our point of view, is how to actually make security usable, and so that is an ongoing area of challenge. And I think we've actually in SE Linux made a lot of really significant progress in the last few years with this. If anyone used SE Linux when it was first released, it was pretty tough to actually get things to work. But now we're seeing, as I mentioned in my talk, probably about 70% of people leaving SE Linux on in Fedora, which is just a general user operating system. So from our point of view, we don't want people to really know that it's there, the end user. And the other thing is we want to build higher level abstraction so that it's actually useful to people. So chaos mode is an example where we're using SE Linux and namespaces and a number of features to provide a really useful function where you have computers set up in an email garden or an airport or somewhere where you have untrusted users coming to use it, and there's actually no configuration. So this is sort of the high-level abstraction. We're doing similar with virtualization and so on. In terms of being able to have system administrators manage the security policy, that's that's a difficult area where, again, we've got high-level abstractions where you don't need to know the language, you can actually use a graphical user interface. So there have been quite a lot of advances made in this area, but it's definitely ongoing. I don't think it's inherently an unsolvable problem. It's similar to having a complex CPU. You don't necessarily want everyone understanding how to write an assembler so that they can do a spreadsheet, use a spreadsheet. And it just takes time to develop useful and usable applications on top of that. And I think generally security has really only come into kind of people's minds as an important thing really in the last few years since so many people got on the internet. So it's probably a bit behind in the general sort of consciousness of people.
Do you think with developer education, more so that we should head away from bringing so much into the kernel and doing more of a kiosk idea or a zone idea to limit the developers from directly accessing the kernel and having the system? Because I think, there's never going to be a standard in education whether you do a 1-year developer course or you do a university degree. Do you think maybe we should be doing more design and systems to allow them less access to the kernel and more of an isolated space to write in, so anything wherever it doesn't affect the system? Do you think that should be more of the approach?
Well, it's a combination. You want things you want systems that end users, you want to make it easy for them to use it correctly and difficult for them to use it incorrectly. But you also want them to think about security as well, and not stop thinking about it. So definitely any measure that can actually make things more secure by default, and I think all the major operating systems now are doing this. I know OpenSolaris, Linux, even actually I don't really know much about what's going on in Windows, but they claim that it's more secure. I don't know, somebody who uses it can probably answer that. But I think we're now moving to it where there's an expectation now at least that systems are more secure by default and come out of the box with good defaults, and I think we can see that in browsers, web browser security now. Firefox for a long time led, and so did Opera, and Safari, and I guess, again, I haven't looked at Internet Explorer, but I'm assuming that they've started trying to catch up on the security there. So we definitely want people thinking about things. We also do want to make it as secure as possible without thinking about it. So yes and no.
Maybe my question is related. I will phrase the question and then explain. Are we prepared to use a specific purpose machine instead of general purpose machines? The idea is when you have a machine that does everything, a computer can do everything if you put the right device attached to it. And then you say to people, okay, here you have a machine that can do everything, but I'm going to restrict you to do something, just some things. Probably some people naturally will say, okay, why, if I have this powerful machine, I'm restricted to that, and I try to break it. And then, but on the same way, people want more things on their machines. I mean, I see some icons there or small things, browsing the internet and everything. So we are putting a lot of features in machines, and what we do is, or what we want is more features in the machines, and then tell the people on security, okay, I put all these features in the machines, and then the machine is not secure, and fix it. So what we have to do first, restrict people, and then grow in an orderly way, or try to fix the mess as we go.
Oh, sorry, I didn't want to answer that.
I have a comment on that. We've had appliance items that do small tasks for a long time. We have appliance routers, we have appliance switches, we have appliance storage devices, we have appliance phones, we have appliance SAN equipment, disk arrays. And we've had security problems on switches, we've had security problems on storage appliances, we've had more security problems than anything on routers. I don't think restricting scope really helps at all. I mean, even the simplest of Nokia phones with Bluetooth and Symbian are potentially exploitable to a Bluetooth distributed virus. So restricting functionality doesn't help security, it just narrows things, and leads to more variety of devices out there, which probably leads to less QA on the actual devices. So in a way, more general purpose equipment means there's less distribution of resources for quality assurance.
So, just one more comment. There was some talk about hacking, hacking as a way of motivating people to think about security, but isn't it true that, if you read, say, Bruce Schneider's sort of columns, he's much more interested in working out, he will think about traditional cons, he will think about, traditional cranks, he will think about anything where you subvert some kind of business model or assumption that people have upon which they've based everything. I mean, the sort of typical thing with Microsoft, Andrew Tridgell made reference to where Microsoft were allowing the clients to tell the server that they'd sanitized the path to something in SMB. And of course, if you turn this bit off and passed in an unsanitized path, devout, it just, will scream the server. And so it's like, let's do a good demo. Let's have something where as soon as you walk up to your house, the door automatically opens for you. And then they spend the next 10 years trying to work out why the door opens to random people. And it's the fundamental mindset of just thinking about comms, thinking about social engineering, all of those things surely feed a security mindset even more than just straight hacking of computing.
I agree, and maybe you could include like a lock-picking course as the first year university computer. You actually get a real lock-picking, because that's, they do hacker conventions now, they often have workshops, and it's definitely a mindset, and if you're training engineers who've got to write the software that's got to withstand attacks from these people, they need to sort of walk in those shoes for a bit.
Just a quick one about the curriculum development for education. We don't need to reinvent the wheel. The ACM, Information Assurance Curriculum, workshop was held last week in Paris, and that curriculum we'll see early next year fully developed. At the same time, that'll be approved by the ACM and the IEEE, will be a major curriculum. At the same time, for those, so if you want to find that, go do a search on ACM, Information Assurance Curriculum. It should come up very quickly. The workshop is there. The second one, we've already got a curriculum that's been there for 15 years, 16 years. Do a search on CNSS 4011, okay, which is the United States Government Information Assurance Teaching Curriculum, 4011 to 4016. The other 6 curricula which are formed for educational purposes, okay?
My question to you then would be, are those free available and open source available for universities in any country?
Yes, absolutely. 100% spot on. The ACM on IEEE will actually be based around the 4011 to 4016. If you go to the web, if you just do a search, CNSS 4011, you'll actually see the full curriculum for the development. So that's the first one. So things are changing. This is good. The second one about user-friendly security versus, I think we've always manager-friendly security. The end user shouldn't see it. For example, in SE Linux, we really should make that transparent to the end user. What we're talking about is making the setup simple for the CIO, the security manager, whoever it be, in enterprise. That's what we really need. And we had that in a system called Trusted Solaris. Trusted Solaris version 8, which was a very, very good system. Unfortunately, it's been discontinued. So we don't have it anymore. Yeah, but it's not the same. Yeah. Yeah, the way the kernel, it's different. Maybe I'll change the Solaris 11 SE. We haven't seen Solaris. Anyone got 11 yet? SE?
Well, you can look it up. Solaris is going to see the next year.
Okay, fine. But at the present moment, I think Trusted Solaris 8 was a good example of what to do to try and make it manager friendly. If we can port that across further into the SE Linux environment, which we're doing, I think we're good success.
Well, the fullest definition of fits in cross extension of the same as you had in Solaris. Just the implementation that is different. Instead of having the implementation of kernel with secure separation with containers, and actually Trusted Solaris extensions is
Trusted Solaris extensions are actually much easier to get installed and setting up because you have prototypes both for kind of classic military information where you have hierarchical structure, but you also have a horizontal structure where you basically can take a template and deploy the template and you have your system set up for you. And then I found that the management of trusted extensions are a lot easier than it was in Trusted Solaris. But most of the configuration details are the same. So you can basically take the configuration from Trusted Solaris and you can deploy that on trusted extensions. But some of the implementation differences are different.
In the network sector.
Network, yes.
Network sector is slightly different.
Slightly different, yes.
As someone who calls themselves an engineer, the drama I've always had is making a business case for doing stuff that doesn't tick off functionalities. So you can make the business case for hiring another couple of engineers to work on things to make deadlines and stuff. So it's all the stuff like sitting down and thinking about security and stuff where you can't actually make a business case on the project budget or schedule for doing this sort of stuff. And it's not just security, but it goes things like testing and documentation. There's a lot of things where it's always, yes, if we have any time or money left, we'll do those things, but it's never happens. So, yeah, I don't know, maybe we need some engineer management training or something like that.
Having been in that situation before, quite a bit, two words, risk management. A project that's not got a formal risk management strategy and is not addressing the risks is the same project that's not doing the things that you can identify as being necessary or successful in product.
No, it's no legal liability. Software has no legal liability, so there's no risk management from the company's point of view. They're not going to be sued. The user statement says, we don't care. Stuff's your system.
If you break it, we can feed both parts.
But you can also just list what all the risks are in the risk register and job done.
To a point, I mean, once you've identified those risks, companies can avoid their public liability by not addressing risks which have a high probability of occurrence. If you're an engineer, you're probably a member of a professional organisation, and you do have a responsibility under your code of ethics, I would hope, to try and address those risks and to make them aware to management as much as you can. And yes, they may turn around and say no, don't spend any effort on this. But at that point, they've made that decision as their risk mitigation measure will ignore the risk.
And developers' pride is the best thing. Free software works, the fact that your name is against it. If your software is security holy and everyone's getting exploited because of it, you're going to look like that. So if the manager goes, no, you can't fix security holes, you can go, well, I'll go work for myself, off the project, fix up the security holes and make a whole lot of money that way and make yourself look good. So there's the advantage there of free software models, which goes on to the whole thing of tools, at least in free software development. If they're not free and open source software tools, they're irrelevant. On the broad scheme of things, although they're much wider use. Just half an hour ago. So it's a real issue for us. I mean, for a development community, only having one person able to check the security holes using an automated tool is not exactly a sustainable way to run a project.
So we're running near the end of time, so I'm going to ask the panel if they have any final thoughts that they want to make before we wrap up for the reception.
I have a question. We have found that a lot of what we would say simple bugs, right? They're buffer overflows. And you go back to the developers and they tell you, oh yes, it's a buffer overflow. But it's not that important, so it can get fixed. I mean, why is that?
One last hand grenade. The point is, if I say struct int and then long and close it, no one here can actually tell me the size of it. The language isn't precise.
That's correct.
And that causes problems. Portability problems, security problems. You know, as the middle speaker said, you know, we need a new system for security. Maybe that underlies a need for a new system programming language as well. And I said, no, I don't mean an existing one. You have to have a low-level system programming language.
But you probably need basically low-level secure hardware base, and we've had them in the past in Multics, IBM System 38, AS4000, Intel 432. But these things were too complex for people to bring the general purpose plethora of software to. And if they did bring them to them, the costs would be so high that no one wanted to use them. And that's why we have Windows as a virus.
Yeah, as a personal experience with when we were working on the TCP and IP security project that I presented today, we dealt quite a lot with different vendors, developers from open source projects, commercial vendors, and so on. Actually, had quite a few discussions within the IPF. And one thing that I personally learned myself is that, for example, when it comes to computer protocols, in many cases people think that the only thing that there is to secure those protocols is crypto, right? That's the case, for example, with IPv6. So when you hear about it, when you hear about the supposed improvements that it has in security, or the improvements is supposed to be that it has IPv6 included in it. But there's so much more to it that people actually ignore. When it comes, for example, to the case of IPv6, you realize that for one reason or another, IPv6 is not going to be used, or it's not actually being used, and you end up facing all other type of issues that we face in many protocols, such as how you allocate memory and that kind of stuff. And that's something that I found like quite interesting, because for many, when we're working on this project, the attitude of many people was, well, if you want to secure the protocol, use crypto, and that's it. And there's much more to it, much more to it. And actually, in many cases, as I said, there are scenarios in which, for one reason or another, you cannot use crypto, and then you have to go back to those more trivial issues, if you want, or not trivial, but things like the ones that I presented today. Okay, how you allocate memory, how you impose limits, and all that kind of stuff that people is not paying attention. And the same type of problem that we have found in the last 20 years in IPv4 are probably going to be found in other protocols such as IPv6, because people are not paying attention to those issues because they think that crypto is going to save their lives. Crypto is not going to save their lives, and actually probably they are not going to use it either.
Perhaps because the 6 users of IPv6 seem to be quite happy in their own world. I heard there was a conference where people were very happy. It's a joke, but it's true. I mean, if you look at actual IPv6, who here exclusively runs IPv6?
China.
Try Asia exclusively.
I was going to say, you can't afford to be exclusive about that. So many things break.
So if we could just thank the panel, and then we'll run up to the reception. So thank you.
Gareth? So what is your preference? Do you want
Do you want the backpack? Or just, or I can just give you something like this? Okay. Well, you're not getting it till tomorrow, but you will have it in the backpack then.
So you're taking it back to the
No, it's staying here because I'm not coming back in the morning.
So you're not coming here tomorrow? Will somebody else manage the camera?
James from the orange shirt. Thank you for that. John, can you give me back my plug?